This presentation will talk about the MultiPACK project, a project that is European founded by the European Union. The presentation will have different parts. We present the project, we'll give an overview of supermarket installation, the challenges with monitoring, the performance of the supermarket, and the reliability and serviceability of the systems. We also give a similar overview of the HVAC systems has been installed in hotels. MultiPACK is the demonstration of the next generation standardized integrated cooling and heating packages for commercial and public buildings based on environmental friendly carbon dioxide vapor compressor cycles. It's a project funded by EU under the Horizon 2020 and started in the October of 2016. It's supposed to last for 3 years, but due to some challenges with the installation and also many challenges with the COVID-19 outbreak, the project has been prolonged and will finish in the September of 2021. As public and commercial buildings, we have 2 focus areas, the supermarkets and the high energy demanding buildings, which are mainly hotels. There is a website of the project that one can visit and get more information of the project and the activities. There are many partners in the project covering all the value chains from the initial idea, innovation, academic work up to the actual end users. From the academic community, NTNU, the Technical University of Norway, is the coordinator. And our research center, our SINTEF from Norway and CNR from Italy are taking part in the project. Danfoss and NX as a producer and a system OEM are part of the industrial partners, and Sonae, an end user, a supermarket owner from Portugal, and Reis, the contractors who support the Sonae supermarkets, are also partners in this project. The objective of the project is to set up installation and monitor them. 6 demonstration sites will be in South Europe. 3 will be for supermarkets and 3 sites will be for hotels. The systems are integrated, cooling and heating function, based on CO2 packs utilizing also ejector technology and other controlling technologies to optimize the system and reduce the energy consumption. They are fully instrumented systems, and there is a detail and should be a detailed monitoring for minimum 1 year for each installation. Analysis of system performance and ejector performance is part of the objectives. Dissemination of the results to technical and non-technical forums, and training material, development of training material for service people and contractors. We'll go towards a supermarket overview of the installations and the systems we have used under the MultiPACK project. The systems are fully integrated, providing both refrigeration and heating or cooling of space, so air conditioning. And the systems utilize carbon dioxide as refrigerant. System of providing the energy flow and demands in the whole supermarket building. starting from the cooling for the refrigeration of the food and goods safety, air conditioning for the space cooling, heat recovery that covers space heating according to the climate and needs, and also hot water production for sanitary use. There is additional heat pump function for additional heating if that's needed. These kinds of systems are suitable for South European climates. They're based on a CO2 booster system, and there are additional technologies on it that reduce the energy consumption and make the system more optimal. And that is parallel compression, overfeed evaporators, and ejectors for both vapor pre-compression and liquid recirculation. There is a DX cooling and a dehumidification. Those kinds of systems are scalable and they are adaptable to different loads and sizes of supermarkets. In order to fulfill the objectives, we have installed 3 installations of supermarkets that they are fully monitored. The target is to build up confidence for standardized disintegrated cooling and heating packages, demonstrate the energy performance in the warm climate of the South Europe, and demonstrate the technical feasibility of those systems, the reliability and the serviceability. There are 3 installations, one in Portugal, in Portimão, and 2 installations in Italy, one in the center of Italy and one north. If we look with a little bit more details on the actual systems, this is a system in Portugal, which is owned by one of the partners of the MultiPACK project. The system has an area of 2,400 square meters and a request of 100 kilowatt of empty cooling, 24 kilowatt of LT cooling, and a demand for air conditioning on the level of 180 kilowatt for summer, and a demand for heating of 160 kilowatt, covering the cold weather in winter. As mentioned before, the base is a booster system concept, and there is a parallel compression, and the expansion work recovery of means of ejector is done in order to compress the vapor, pre-compress the vapor, but also to recirculate the liquid. With the possibility of the recirculation of the liquid, we can run the evaporators overfeed. That means we will have higher suction pressure at the evaporators, providing the requested cooling. The system satisfies also heating and cooling demand by direct flow or direct expansion to the 2 air handling units. The direct flow is utilizing again the expansion recovery of an additional pack of ejectors. And this is a technology, an individual technology of itself that is add-on on the system. There is a domestic water heat, a domestic hot water production based on heat recovery. There's a heat pump functionality, dehumidification, and the system is fully monitored. The installation started in December 2018, and the ejectors were commissioning in 2019. And it's monitored since the beginning of 2019. Various modes of operation has been performed in the system, and after a year of operation, we have done fine-tuning, and also we add some different control strategies in order to optimize the system and get more benefits on the energy reduction. There are two more systems in Italy that are based on the same principle and technology with similar or a bit different loads. The one in central Italy was installed in April 2018 and is monitored since the end of 2018, while the one in North Italy was installed in the middle of 2019 and it has been monitored since June 2019. The system is also similar, but it has a particularity that the heating and cooling is satisfied by direct flow into the distributed indoor units cascade. Monitoring performance overview. Monitor a system and analyzing the data and translating the data to a useful information is one of the most important tasks. And it's not an easy task either. We have two monitor systems in each of the installation. One is the monitor, the Danfoss one, via the pack controllers and system manager. And these utilize and record all the parameters that they need to be recorded in order to control the system, in order the controllers will work. And here we have about 170 parameters that they are recorded every 2 minutes. We have an additional system that is fully instrumented with pressure transmitter, temperature sensors, flow meters, and energy meters. And there are about 150 parameters that we record every minute. This, as you can understand, will give a huge amount of data. On the left, we can see two plots. One on the top, it shows 4 parameters of pressure for only 1 week, while the one on the bottom, it shows for the same week the energy meters, 3 parameters. So if we imagine that we have more than 300 parameters giving data every minute or 2 minutes, we can realize that the data and the information is huge, and it has to be analyzed in the way to give sensible information, and has to be treated in a way that we can extract information out of it. The parameters are showing physical parameters as pressures and temperature, but also it can give information about opening degrees of components, capacity of compressor, or even status of individual components. All instruments need to be calibrated on site, and all data need to be evaluated for the quality and the validity before we moved on the analysis and the conclusion. For the analysis, we need to use different methods or models that has to be built and developed. With those data, we are targeting the investigation of parameters and performance for both system and ejector. In order to communicate those information, we need to identify key performance indicators, KPIs. And this is a simple way to communicate, because we don't need to present the data, we need to present the results and find a way that we can communicate with both technical and non-technical people. In the MultiPACK, we have as a task to identify a list of KPIs. And here we have a list, which is the reduction level of peak power demand and the reduction of the total primary energy demand that is based on energy meters. Is the reduction in total CO2 emission, the reduction in number of cycling of compressors, reduction of number of separate individual energy transfer units, reduction in total cost of ownership, which is an economical assessment based on the first cost, but also the operational cost. Operating temperature pressures for evaporators, and the average second law efficiency, which is an indicator that can be used to show the energy consumption independent of the ambient temperature or the load of the supermarket, and can be easily used for comparisons. Key performance indicators are also very important for comparison because we need to compare the system with something. Otherwise, we can't conclude for the benefits of the system. We refer to those systems as benchmark supermarkets or benchmark systems. This can be a system like systems with a different technology, like cascade or synthetic refrigerant, or even a simple booster system. And what we try to do is to compare the operation of our integrated system with those kind of system and extract results and conclusions. For the Portuguese supermarket, we have a supermarket in the vicinity in the same region, which is a Cascade CO2 R134A owned by the same company. And it has an additional rooftop unit as an air conditioning. The supermarket is on a similar size, both in area and in a cooling requirement. It has some energy meters for some periods, but it's not fully monitored. And this is actually the main challenge when we're talking about benchmark supermarket. It's very difficult to find installations that are fully monitored in a similar level with our new installations. Also, it's a challenge because the supermarkets are not identical, neither are size, not on operation. For the Italian supermarkets, we have some benchmark supermarkets from the same region, mainly with CO2 booster technology, but it is still possible to include additional sites. This is an example of the position, location of instrumentation for the Portsmouth supermarket. The location of instrumentation is also a parameter needs to be considered, especially when we're talking about temperature transmitters, because if the location is not correct, then the temperature transmitter can be influenced by other thermal sources, and then the result we'll get is not the one that refers to the system. So there are a lot of challenges with handling of the data, and I would like to summarize and give some highlights on that. Now, for the monitoring, a failure in calibration or a failure in the sensor measurement is a challenge. Non-optimal location of the temperature sensor can give us two wrong conclusions. We can have potential problems with the acquisition. Internet problems can occur, storage problems can occur in the controllers, and we can lose a period of data that it might be very important for our analysis. Planning beforehand is needed to ensure that all sensors are in place, all sensors are correctly calibrated. For the comparison, we have the challenge of the different sites, different installations. The sites are operating differently. They might have different loads. They might have different operational times. They might have different ambient temperatures. So it's not always easy to compare one by one to sites. And it's good to define KPIs that they normalize some of these parameters in order to do a fair comparison. For data handling, validity, verification of the quality of the data, cleaning of the data will most probably need it, filtration of the data will most probably need it. And then we can set up an analysis model and also utilize data-driven model to cover parameters that they haven't been measured or they cannot be measured. Another aspect in our objectives is to look more on the reliability and serviceability of the systems. We had a discussion with the contractor, Race, about the system in Portomas. And Luis David said us that the system is working as a Swiss clock, and there are not many issues to solve. The system is fully operational. They don't have, or they haven't had any of the set-off alarms or other critical alarms. It operates in all modes and supply the required cooling for both LT and MT anytime. There is a flexibility in the pack, and it also allows the installation of the dehumidification function, which wasn't planned in the first place. They haven't had leakages, so they have zero CO2 filled after commission. After the full commission, after the ejector started, they saw an energy reduction. And comparing the bills, the energy bills, with similar installations that they own, then they can see a significant reduction in the energy consumption. For the serviceability, a training of service people is required. Service people from Race received training from MultiPACK Project. They found it very useful, and they believe that more hours of training can be always beneficial, and something that the contractors need to invest on this training time. Their opinion is that the service of integrated system is not difficult, and the integration is quite simple. However, they need to have versatile service people with integrated minds. With those kind of systems, they cannot continue having two teams. Traditionally, there were two service teams, one for the refrigeration and one for the heat pumps. Now, in those systems, as the system is one covering all function, then the service team should be one, servicing all functions supported by the system. The problem and the main complication, as I said, is not technical, it's mainly logistic. The HVAC installation is owned and operated by the building owner, while the refrigeration installation is operated and owned by the supermarket owner. And now they need coordination and alignment, as the system is one, but the owners will still be two based on the traditional SER. This was my part.